Good day, everybody. How are you all doing? Today, we are going to talk about measures of position. Measures of position of a data set. So, here I go. So first we will compute z-score. Who is taller, a man 73 inches tall or a woman 68 inches tall? The obvious answer that is that the man is taller. However, men are taller than women on the average. Suppose the question is asked on this way: who is taller relative to their gender? A man is 73 inches tall or a woman 68 inches tall. One way to answer this question is with a z-score. Then we will be comparing apples with apples. That is, men will be compared to other men in that gender group, and women will be compared to other women in the gender group of women. Let X be a value from a population with a mean mu and a standard deviation sigma. This population mean is Greek symbol mu and the population standard deviation is sigma. And X is any other value in that population. So we define the z-score as X minus mu. That is how far the number X is located away from that mean of the population, X minus mu. The difference is divided by sigma, which is the population standard deviation. The z-score of an individual data point tells how many standard deviation the value is from its population mean. So z-score will be a number. If X is greater than the mu, then the z-score will be positive and it shows how many standard deviation the value X, how many standard deviation or how many times standard deviation is the X score above the mean if X is greater than the mean. If X is less than the mean, then the z-score will be negative and it tells us how many standard deviation the number X is below the mean. For example, a value of 1 standard deviation above the mean has a z-score of 1 and a value 2 standard deviation below the mean has a z-score of minus 2. Key point here: if z-score is 1, that means the particular number X is above the mean, greater than the mean. And if the z-score is negative, it means the particular number X is less than the mean. And the z-score tells you how many standard deviations you are away from the mean. The National Center for Health Statistics study the states that the mean height for adult men in the US is mu equal to 69.4 inches with a standard deviation of sigma equal to 3.1 inches. The mean height for adult women is mu equal to 63.8 inches with a standard deviation of sigma equal to 2.8 inches. Who is taller relative to their gender? Man 73 inches tall or a woman 68 inches tall? So what do? We take the man's height of 73 inches and convert it to convert it to a z-score. How do we do that? We take the height of 73. From that, we subtract the mean of the men, which is 69.4. And then that difference is divided by 3.1, which is the standard deviation in man's height. So the z for a man who has a height of 73 inches is 1.16. What does it mean? It means this number 73 is 1.16 times standard deviation above the mean for the men's group. We do the same calculation for the woman's height of 63 what is it? Of 68 inches. Now, 68, we convert that to a z-score. How do we do that? From the woman's height of 68, we subtract the woman's mean height of 63.8, divide that difference by the standard deviation in women's height, which is 2.8, and we get a number of 1.5. So when we convert to z-score, it looks like the woman's height of 63.8 is has a higher z-score compared to the z-score for the man with a height of 73 inches. Sometimes we are given z-score and need to find the value that has the z-score. That means we'll be given a z-score. That means we'll be given how many standard deviation the X value is above the mean or below the mean if the z-score is negative. and then we have to find the X score for that. So how do you do that? You multiply that z-score with the standard deviation of the distribution and then add the mean to it. Okay. Data from National Health and Examination Survey estimate that the mean total cholesterol level in milligrams per deciliter in the adult population to be mu equal to 200 with a standard deviation of sigma equal to 44. What is the cholesterol level for a person with z-score of 1.5? So we take 1.5 multiplied by the standard deviation. 1.5 times 44 is 66, and then we add the mean to it. So the X score for a person who has a z-score of 1.5 or X value is 266. X value is the man's cholesterol level. Z-scores for an empirical rule. As indicated, one standard deviation above the mean will have a z-score of 1. One standard deviation below the mean will have a z-score of -1. So if the horizontal axis is converted to a z-score, the center is z equal to 0. On the right of z equal to 0 is positive. On the left of z equal to 0, left of that is negative z-scores. Okay. And here we see the empirical rule. Approximately 68% of the data will fall within one standard deviation of the mean. That means between z-score -1 and +1. Similarly, or in the same fashion, approximately 95% of the data will fall between z-score of 2 and z-score of -2. According to Wall Street Journal, the maximum distance from check-in to the gate at the top US airports has a mean of 0.79 miles and a standard deviation of 0.42 miles. The maximum distance at the Seattle Tacoma International Airport is 0.57 miles. What is the z-score for this distance? So from this x value of 0.57, we'll subtract the mean of 0.79, which will be negative, and then we'll divide the difference by 0.42 to get a z-score uh, for Seattle Tacoma. So we do 0.57, which is the x value for Seattle Tacoma. From that, we will subtract the mean, which is 0.79. We will get a negative number, and then we will divide it by the standard deviation of 0.42. Okay. So the z-score for Seattle Tacoma with x value of 0.57 is negative 0.52. What does it mean? That the Seattle Tacoma distance of 0.57 miles is located 0.52 times standard deviation below the mean because it is negative. Okay. The airport, the maximum distance at the Hartsfield-Jackson International Airport is 1.67 miles. What is the z-score for this distance? So we do 1.67 minus the mean, which is 0.79, get the difference and divide it by the standard deviation, 0.42. And the answer is 2.10. What distance would have a z-score of 1? So we take the value z-score of 1 multiplied by the standard deviation, which is 0.42. 1 times 0.42 is 0.42. And then, so we took the z-score of 1, multiplied it with the standard deviation, which is 1 times 0.42, which is 0.42. And then we add the mean to it, plus 0.79. And it is 1.21. Compute the quartiles of a data set. What is quartile? It's like a dollar has 4 quarters. So we divide a dollar, 100 cents, into 4 quarters. The first quartile is represented by Q1. That means 25% of the data are below Q1 and 75% above Q1. Like you have 25 cents, 1 quarter, you have 1 quarter or 25% of the 100 cents. You do not have the remaining 75 cents or 75%. Second quartile is denoted by Q2 is actually the median because it's a 50th percentile. 50% of the data are below Q2, 50% above Q2. Third quartile denoted by Q3, that means 3/4 of the data, or 75%, is below or at Q3 and 25% above it. So, how do we compute the quartiles? Later on, I will show you an easier way to do that. Do you have a data set to show it? Okay. No. So let's do the quartile of this data set using our calculator. So we will enter all the data in L1 of the calculator. Second plus 4. Clear all list, done. Stat 1. In list 1, we will enter the data, which is 0, 0, then 0.03, then 0.08, then 0.16, then 0.17, then 0.2, then 0.29, then 0.56, then 0.7, then 0.79, then 0.83, then 0.92, 1.22, 1.3, and 1.48 in the first row. Then 1.64, I'm entering all these values in L1 of the calculator. 1.72, 1.9, 2.37, 2.84, 3.06, 3.12, 3.21, 3.29, 3.54, 3.57, 3.58, 3.71, 4.13, 4.17. That's the last number in the second row. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 30 data points up until the second row. Now we are in the third row. 4.27, 4.37, 4.64, 4.89, 4.94, 5.54, 5.59, 6.1, 6.61, 7.96, 8.87, 8.91, and then 11.02, 12.75, and 13.68. So 45 data points in L1. I want to calculate the first quartile. How do I do that? I press the stat button, highlight calc, that is move the cursor on the top row on top of calc, then select number 1, which is one where stats. My list first line is always L1. My second line after the colon should be empty. If there is something, press the clear button on the third row to clear everything on the second line after the colon. And they don't go down to calculate and calculate. Okay. So my first quartile, I got 0.875 and they got. So let me check on my numbers. I might have entered one number wrong. Let's go on the data set. So it's 0, then 0.03, 0.08, then 0.16, then 0.17, 0.2, 0.5, 0.2, then it is 0.29, then 0.56, 0.7, 0.79, 0.83, 0.92, 1.22, 1.3, 1.48, then 1.64, 1.72, 1.9, 2.37, 2.97, 2.97, nope, 1.5, then 2.37, then 2.84, then 3.06, that's fine, 3.12, 1.92, okay. Then 3.12, 3.21, 3.29, 3.54, then 3.57, then 3.59, 3.57, then 3.58, then 3.71, yep, and then 4.13, then 4.17, next is 4.27, 4.37, 4.64, 4.3, 4.64, then 4.89, then 4.94, then 5.54, 5.59, 6.1, 6.61, 7.96, 8.87, 8.91, 11.02, 12.75, and 13.68. Okay, then stat calc 1. Calculate. Okay, first quartile is 0.875. Second quartile is the median is 3.21, slightly different from what they have. And the third quartile is 4.915. Okay. So this is the picture. You see the smallest data value is the minimum, then the first quartile, then the second quartile or median, then the third quartile. There's a huge gap between the third quartile and the maximum value. So above the third quartile, 25% of the data, below the third quartile, 75% of the data. Okay. So percentiles of a data set. Quartiles describe the shape of a distribution by dividing it into four quarters. Sometimes it is useful to divide the data set into a greater number of pieces for a more detailed description of the distribution. Percentiles, as the name implies, divide the data into 100 equal parts. For a number p between 1 and 99, the pth percentile separates the lowest p% of the data from the highest 100 minus p%. As the figure shows here on the screen, 98 percentile is a number below which 98% of the data fall and above which 2%. 100 minus 98 is 2% of the data fall. Arrange the data in increasing order. Let n be the number of values in the data set. For the pth percentile, compute L is p divided. So if I want to find 20th percentile, I put p is equal to 20. 20 divided by 100 is 0.2 multiplied by the sample size. If L is a whole number, the pth is the percentile is the average of the number in the lth position and L plus. So whatever the L value, if L is a whole number, if L comes out as a whole number, we take the value in the Lth position and the next position, L plus 1th position, and take the average. If L is not a whole number, we round it up to the next higher whole number, and pth percentile is the number in the position corresponding to the rounded up value. So they want to find that 60th percentile. 60 divided by 100 is 0.6 times 45 is 27. It's a whole number. So we take the number in the 27th position and 28th position, add them up, divide by 2. That gives you the 60th percentile. Okay. Sometimes we are given a value of a data set and wish to compute the percentile corresponding to that value. Following is the procedure for doing this. Arrange the data in increasing order. Let x be the data value whose percentile is to be computed. Use the following formula to compute the percentile. So we find out how many values are below x. So we have arranged the numbers from the lowest to the highest, locate the x, which is a particular value in the data set, count how many numbers are below x, then add 0.5 to it and divide by the total number of values in the data set and multiply it by 100. That will give you the percentile. So they want to find out what is the percentile for 1.9. There are 17 values which are less than 1.9 in the data set, above data set. So 17 plus 0.5 is 17.5 divided by the total number of data points, which is 45, and then multiplied by 100 gives you 38.9. and we round the result to 39. What does it mean? 1.9 is in the 39th percentile position. That is 39% of the numbers are below 1.9, and 100 minus 39, 61% of the numbers are above 1.9. For the years 1882 to 2019, the 90th percentile of annual snowfall in Denver was 80.3. Approximately what percentage of years had the snowfall less than 80.3? So this is the 90th percentile, 90% of the years less than 80.3. In a year, 65th percentile of daily mean temperature in the city of Macon, Georgia was 78 degrees. For approximately what percentage of days that year was the mean temperature greater than 70? So it's 100 minus 65, which is 35%. Okay. And in a recent year, 17% of the players in the National Football League weighed less than 200 pounds. On approximately what percentile is a player who weighs? That player is 17th percentile, because 17% is below 200. Okay. Okay, let's enter this data in L1 and calculate the first quartile. So second button plus and then 4. Clear all list, done. Let's enter these values in the data set. So stat 1. In L1, I'm going to enter this data set 58, then 59, then 62, then 64, then 67, then 68, then 69, then 71, 73, 74, 74, 75, 76, 76, again 76, then 77, 78, another 78, another 78, 378, 378, yes, 378, then 282s, then 84, 86, 87 twice, 88, 91, and 97. First quartile we have to find out. So stat, calc, 1, list is L1, calculate. What is the first quartile? Q1, 70. That means 25% of the numbers are below 70. Okay. Third quartile, Q3, is 83. That means 75% of the numbers are below 83. What is the percentile score for 73? How many numbers are below 73? 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 0.5 is 8.5, divided by total number of numbers, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 8.5 divided by 28 multiplied by 100 is the percentile position, which is 30th percentile. That means the number 73 in the 30th percentile, 30% of the numbers are below 73, 70% above it. Students' scores are on the 80th percentile. Students whose scores are on the 80th percentile above will get grade of A. Louisa got a grade of 88. So 88, what will she get an A? The question is 88 and 80th percentile? So what is the percentile position of 88? So we are given 88. How many numbers are below 88? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 14, and then 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So it is, if she got 88 on the exam, so 25 numbers are below 88. So 25 plus 0.5 is 25.5 divided by 28 and multiplied by 100 is the position percentile. So for 88, the percentile is 91. That is 91% of the numbers are below 88. So 88 is 91st percentile. And if you get 80th percentile or above, you are going to get an A. So she will get an A. Compute the 5-number summary of a data set. Minimum, first quartile, median, third quartile, maximum. These 5 numbers comprise the 5-number summary. Okay, again, they get the 5-number summary of this data set. Okay. So what is an outlier? Outlier is a value that is far away from the rest of the lot. How do we find outliers? Okay. So this is these are the temperatures measured during the summer. Look at all the temperatures. They're in the 80s and 90s. Suddenly there is a number 8.45. Looks like that number has been recorded wrong. It should have been 84.5. So clearly we can say 8.45 is an outlier in this case. The following table presents the population of the 5 largest cities in the United States. Which reading is an outlier? Okay. Notice except New York, all of them are 1, 4s, 2s in this. So 8.6 is an outlier for New York. Technically, how do we find out an outlier? We first calculate the interquartile range. Notice the definition of IQR or interquartile range is Q3 minus Q1. What is Q3? 75th percentile. What is Q1? 25th percentile. 75 minus 25 is 50. So interquartile range basically gives the spread or the range of the middle 50% of the data. So first we find IQR, then we multiply it by 1.5 times. And we create 2 boundaries, lower outlier boundary, which is from the first quartile, we subtract 1.5 times IQR. So this is the boundary on the left. Any numbers lower than that will be an outlier. And we construct an upper outlier boundary, which is Q3 plus 1.5 IQR. Any number greater than that will be an outlier on the right. So here is it. And these numbers, is there any outlier? Cursory glance, maybe 100 is an outlier. Let's do it. We calculate Q3 minus Q1, that is the interquartile range, which is 14, multiply 14 by 1.5. 1.5 times IQR is 21. So from the Q1, we subtract that 21, gives 24. Any number less than 24 in this data set? No. And then Q3 plus 1.5 IQR gives you the upper outlier boundary, which in this case is 59 plus 21 is 80. Any number greater than 80? Yes, 100. 100 is an outlier. So similarly, we can do this. So let's do this one. Second plus 4. Clear all list, done. Stat 1. In L1, you enter the data 48, 79, 217, 92, 6, 96, 113, 143. I'm thinking that is a 180, 180, then 1081, 724, 1803, 522, 1203, 1203, then 968, then 3721, 907, then it is 484, then it's 214, 325, 346, 169, 320, 381, 166, 364, 291, 277, and 114. Okay, so enter the number in L1. 5-number summary is stat. Highlight calc on the top row. Then number 1, list is L1, calculate. Okay, so minimum is 6. They say Q1 is 140. Okay, I got Q1 of 128.5. Maybe I entered a number wrong. Okay. My median is 291, their median is 284. My Q3 is 623, their Q3 is 522, and the maximum is 3721. What is the IQR? In this case, it will be Q3 minus Q1. 522 minus 140 is 382. That's the interquartile range. Upper and lower boundaries. So from Q1, you will subtract 1.5 times 382. Gives you a negative number. Any number lower than that on the left-hand side? No. No outliers on the left. And then Q3 plus 1.5 IQR gives you 1095. Any number greater than 1095? Yes. And these are in the second row, you have 1803, 1203, and the last number you have is 3721. That's also in the second row. These three numbers in the second row are outliers. Okay. Box plot. Same information can be done with a box plot. How do we make a box plot like this? First of all, the box plot, the box consists of the two vertical boundaries of the box. The one on the left is Q1, the one on the right boundary is Q3, and the line in the middle of the box is Q2 or median. The box plot would extend to the minimum value on the left, and that's called the left whisker, if the minimum value on the left is not an outlier. Similarly, on the right, it would extend to the maximum value if the maximum value is not an outlier. But in this particular data set that we have entered in L1, there are 3 outliers. So the box will or the whisker on the right horizontal line will extend to the number just below the first outlier. So how do you make a box plot? Well, you press first you press Y equal to key, and this you only do once. Make sure you will see Y1 equal to, Y2 equal to after you press Y equal to key. That's on the top left. On the right of the equal to sign, there should not be anything. Normally, there is nothing, but make sure that's the case. Then you press the second button on the top left, and then Y equal to key. Second and Y equal to key. Then select number 1, okay, which is plot 1. Make sure in the second line is flashing on, okay. Then the type, this is critical. We want to make a modified box plot, which will show the outliers. That is number 3. So in the type, which is the third line, put the cursor, the flashing rectangle, on the 1, 2, 3, fourth type of chart, which is the modified box plot. Why is that important? Because I want to show outliers. So put the cursor on the fourth type of chart and hit enter. It's flashing on the fourth type of chart. Fourth type of chart, which is the modified box plot. Then press the zoom button, which is the third key on the top row, zoom 9. And you see a modified box plot with the outliers clearly shown. Okay. The outliers are on the right. Okay. Let's do a box plot on this one. Okay. So second button, plus and 4. Clear all list. Hit enter, done. Stat 1. In L1, we are going to enter the 2 rows of data. 65, 67, 71, 57, 51, 49, 44, 41, 59, 49, then 42. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So something, yeah, 11 data points in the first row. Next row, 56, 45, 77, 44. After 77, it is 44, then 42, then 45, then 46, then 100, then 59, then 53, and the last but not the least is 51. So in total, there are 22 data points. That's why the cursor is now sitting on the 23rd line in list 1. L1 parenthesis 23 means 23rd line in list 1. We have 22 data points. Now we do stat, highlight calc on the top row, then number 1, one where stats, first line is list 1, calculate, and we get the 5 number summary. What is the 5 number? Min X is 41, Q1 is 45, Q2, the median is 51, the Q3 is 59. So what is my interquartile? And below it is the maximum value, which is 100. What is my interquartile range? It is Q3 minus Q1, 59 minus 45, which is 59 minus 45. 59 minus 45 is 14. 1.4 times 14 is 21. So 45 minus 21 is 24. Is there any number lower than 24 in the data set? No. So from Q1, I subtracted 1.5 times IQR to establish the lower outlier boundary. Any number on the left of the lower outlier boundary, which in this case is 24, would have been an outlier. There is no number smaller than 24 in this data set. So therefore, no outlier on the left. How about the right? So Q3 plus 1.5 IQR. Q3 in this case is 59. 59 plus 21 is 80. Any number greater than 80 in this data set is an outlier, which I think is 100. We can verify that by pressing second y equal to the number 1 and select the 4 type of chart in type and then do zoom 9. You'll clearly see an outlier on the right. Okay, far away from the rest. The right whisker extends to the data value just below 100, which in this case I believe is 77. Yes. So the right whisker or the right horizontal line from the box ends at 77 because 77 is the number below the boundary, upper outlier boundary. Whereas 100 is on the right of the upper boundary, upper outlier boundary, which is 80. Therefore, 100 is an outlier. Okay. So they show you how to do this calculator. Okay, box plots can be used to determine skewness. This is skewed to the right. A box plot will show you. Okay, if the median, that means the line, vertical line in the center of the box, is closer to the first quartile than to the third quartile, or the upper whisker is longer than the lower whisker, then you have skewed to the right. Okay. Opposite. Okay. If the median is closer to the third quartile and the left whisker or lower whisker, lower horizontal line, is greater than one on the right, then this data set is skewed to the left. In this case, the median is approximately halfway between the first and third quartile inside the box. The vertical line divides the box into two equal parts, and the whiskers are approximately equal on the left and on the right. Therefore, this data set is approximately symmetric. So this is what we did today. I will stop here today. If you like this video, please give me a thumbs up. I really appreciate that if you give me a thumbs up. If you like this video, share with your friends. Okay, if you have any question, write me a comment. I'll respond to your comments, definitely. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button on the bottom right corner and let YouTube know that you'd like to be notified every time I upload a new video, which I do almost every day. So please do not forget to watch me tomorrow when I'll be back with another interesting video. Okay, thanks for watching. Take care. Have a nice day. Please subscribe to my channel by hitting the red subscribe button. I have lots of math problems solved just for you in my channel. Take care. Have a nice day.